Hello everyone, I am Nitin Sharma, your chemistry tutor, and welcome to our channel Organic Classes by Nitin Sharma. Today we are going to study about the fundamentals of inorganic chemistry, and that is chemical bonding and molecular structures. This chapter have this chapter have two parts. One is chemical bonding, and second one is molecular structures of inorganic compounds. So first we will discuss. First part will be our focused chemical bonding, how chemical bonding studies, how chemical bonding can be explained in organic compounds, and further we will move to the second part, which will be the molecular structures of the inorganic compound. Okay, so let's start about the first chapter, the first part of the chapter, which is chemical bonding. Chemical bonding. Before studying chemical bondings, we have to study atom, molecule, and ions. I hope I I expecting you to I expecting that you everyone will know about that, what is atom, what is molecule, and what is ions. Okay, so I'm not describing it because uh, I think you all know about this. This is fundamental. This is the basics. So bond first part is knowing about the entity, which is atoms, molecules, and ions. To explain the bondings, we have some species. You know, there should be there must be two species to explain the bonding. For example, if we have two major cities and we have to transport something from one city to another city, we have to connect them. The connectivity can be by road, by air, by sea, by rail, and any kind of connectivity. But first we have to connect those major cities to transport something one city to another city or vice versa. Okay, so to study the bondings, we have to know about the species that are getting involved in a bonding. Okay, and that will be entities includes atoms, molecules, and ions collectively. Okay, so we have two atoms. Okay, they could be same or they could be different. That's all about the particular inorganic compound we have to study. So now we are going to comprehend that what is bonding basically. Okay, look, we have an atom A and we have another atom, let's say B. Okay, this atom has some kind of deficiency, let's say, or let's say this atom has some kind of you know excess excessiveness. Okay, so bondings is a result of getting deficient and getting excessive. If two species, that one is deficient and one is excessive, they will come to a place where they could be neutral. Okay, this this atom A want to be increased, will they this atom A want to neutralize their deficiency, and this atom want to neutralize their excessiveness. So this will donate to atom B will donate to atom A, and atom A will receive to atom B. In similar ways, their deficiency will be lost and their excessiveness will be lost. Okay, and they both will connecting, they are Look at both atoms. They are getting connected by their requirements. Similarly, two cities, let's say Jaipur and Delhi. Okay, we are transporting Delhi to Jaipur to Delhi and Delhi to Jaipur. Let's say by road. Okay, okay. This road is called bond. Similarly, the transfer of the electrons between both atoms, the excessiveness of electrons, you know, driving them to donate to atom A and fulfill the requirement of electron, that is causing deficiency in atom A. This is called bond, and this electron will hold them together, and the force, an electron has some kind of forces. We all know the electron have the negative charge species, and the atom nucleus has positive nucleus. So this electron will hold both atoms by a force, or that force is called bonding. Okay, and that bonding is taking place in chemical reaction or species is called chemical bonding. Okay, now we have to study about the chemical bondings. you know all these things we are comprehending the chemical bonding, and we have done it. Okay, our next step is what theories are came into account that explained the chemical bondings in inorganic compounds, or the in particular organic compounds, or generalized organic compounds. Now we have to study to comprehend, or to move forward. There are four theories that came one by one, and the scientists tried to explain the chemical bondings. And first was causal Lewis structure, or we also called it as a octet rule. And we all know about the octet rule because it is the soul of the bonding. Octet rule is the most famous term you ever know about the chemistry. So to explain chemical bonding, we have different theories. First is causal Lewis theory. It is also known as octet rule. Second one is we have Weissenberg theory. Weissenberg theory is known as valence shell electron pair repulsion theory. This theory totally explains the lone pair in an organic compound and their repulsions, cause the their destruction. Their molecular structures will be changed if there is more repulsion, more and more repulsions. If there will be more and more lone pairs, there will be more and more repulsions in a inorganic compound. So it explains all these things. When a molecule, when a organic compound have one lone pair, two lone pair, three lone pair, and four lone pair, and so on, and what will be the effect of lone pair on the chemical structures. So this will explain the molecular structures of the compound basically. Third one is VBT. VBT, valence bond theory. This will explain all about the valence shell electron and how their valence shell electron will contribute towards the bonding in a bonding. Okay, and third one is MOT, molecular orbital theory. This is the most advanced theory right now, and our all academics up to PG, up to PhD, we all the structures and the reactions and the transfer of electrons and the reactions, how reactions proceed, everything is just on the base of MOT right now. So in a path to study the chemical bond to chemical bondings, we have to study all the bonding theories in a row to comprehend how it evolved and right now how it is going on basically. So we will study to in this lecture we will study all the causal Lewis structures or octet rule. Look, first thing that we have to know the basics of the causal Lewis theory. It is all about the causal Lewis, studied about the noble gases, and we all know that noble gases don't react, you know, uh, except xenon in some special cases. And last chapter, last topic of this chapter will be that particular thing about the reactions of xenon. Okay, basically they are inert. Noble gases are inert. Noble gases are inert. And causal Lewis studied why they are nobles, why they don't react generally. So to study all these noble gases, they tried a concept. They said that there is a complete octet or complete duet in a particular valence shell, that whole that makes them stable. So what is the octet and what is the duet? So basically to study the Lewis, causal Lewis, we have to study both two things. What is duet and what is octet? Whenever there is two electrons in valence shell of any atom, or there will be duet law. I mean there will be a most stable electronic configuration that can have that molecule that have atoms. So what is the example of this duet? This is only one, helium. Helium electron configuration is 1s2. It means there is s orbital and is totally filled, fully filled. Okay, that will be helium. To comprehend something extra about this, the book can tell us that these things, that it has fully filled orbitals and their spin is zero and all things. But why these two in a helium nucleus, only two electrons are stable? Why it can't be three? Why it can't be four? Why it can't be up to a seven, 8, 6? Eight is also stable, but between 2 and 8, why these numbers can't be stable electron? Why these numbers can't make a stable electronic configuration? To comprehend this, we have to study these things, and let's make it possible. Look, we all know there is a concentrated part of an atom that is called as the nucleus of the atom, and this is the helium that have one s orbital and which have two electrons in it. Look, these nucleus holding both the electrons with a z effective, with a nuclear charge. If we enters a more one more electron in this valence shell of a helium atom, there will be helium to helium plus, sorry, helium minus, helium negative. Okay, look, this nucleus can hold this electron easily because its size is small. It can make it possible, there is no worry about it. But we have to look into another half of the concept, that is the repulsion between these atoms. It is totally acceptable that this positive charge is holding this electron with a force of attraction, but there is a double force of repulsion between electrons and electrons that makes this helium very unstable. Okay, that's why there is a two electrons that are most stable forms in a helium, and that is called law duet, and this law is called duet law. And make sure, always remember, this is applicable only for helium. If there is more than two electrons, then they will come into arena of an octet rule. Okay, now we will study about the octet. What is octet? If any atom or molecule or ion that that completes 8 electron in its outermost shell by sharing or by gaining or losing, anyhow they will consider as the most stable electronic configuration we can have. Now, why? Similarly, we asked about the duet, that why helium is most stable in according to duet law. Similarly, why octet rule is only applicable for 8 electrons. Why not is nano law? Why not deca law? What is octet? So look, this is called a magic number. They have studied about the, I think, previous chapter or something, atomic periodic properties. Look, similarly, analogous of this concept, we can explain the octet rule. If we will enter a more electron, 9th electron in the outermost shell of a atom, they will be excessive, not excessive, but there will be more, you know, they will be enough to destabilize this atom or that molecule, and that's why there will be 8 electron, then it would be better for their stability. Okay, now look, after this duet and octet, our next point is what thing that make these two conditions possible. What are the ways to complete their octets, and what are the ways to complete their duet? So duet is all about helium, and that is very very rare kind of things, and in we will study. So our main focus will be octet rule, and we will study how to complete the octet. What are the ways, different kind of ways by which we can explain, and we can comprehend that how octet rule are practically applicable in the chapter. Okay, so look, octet rule can be possible, or the octet can be completed by two different ways. One is by transference of electrons from one atom to another atom. Okay, second is, if there is two atoms and they have some kind of electrons in outermost cell. They can share both electrons. They can share both electrons. Okay. So second is by sharing of electron. By sharing of electron. Okay, that's simple. Look, first we will study all this and then we will jump on this. How transparency? Look, if I will say we have an atom A, and after some applying some kind of energy on it, and it loses a electron and convert into a cation A plus. Okay, it is transferring a electron by out of it, out of atom A, and we have atom B, and applying some kind of and receiving a electron and converting into B negative, which is anion. Okay, anion, and releasing some kind of energy. Okay, now these both things will say you have the deficiency. You have the deficiency. You have the positive charge. Positive charge means you have the vacancy to accept the electron, and I have an excessive charge or excessive electron density to donate you. Let's make a fair deal. I will give you electron so that I can be neutralized, and you have the deficiency and you want an electron to stabilize yourself as well. So let make a fair deal. I will give you electron and you will accept it, and we will hold and we will stay together by a force which is called positive and negative holding force. In a physics first chapter, I guess, there is a formula F is equal to Q1 K Q1 Q2 upon R square. This is called electrostatic force. Electrostatic force, ESF. Electrostatic force. Look, this is positive, means a positive charge. Look, this is negative, means this is a negative charge. This positive charge is stationary, and this is going towards the positive. Negative charge is going towards positive charge at a distance r. From a distance r, means the force of attraction between these two is directly proportional to charge on them. This is q1, this is q2, or upon my square of the distance. Okay, look, this is the same thing that we are studying in chemistry. Now they will come together, and after some time, after time t, they will hold each other by a force. This that is called as electrostatic force. Okay, and in chemistry there will be a that electrostatic force that are holding both these ions is called ionic bond. And whenever this ionic bond will form, every compound that contains ionic bond is called ionic compounds. Ionic compounds. I hope you will get it. Now let's jump on this thing. Sharing could be of two types. Look, two friends, they are sharing. One have chocolates and one have candy. Friends is giving chocolate to another friend, and candy friend is giving candies. They are exchanging some goods to each other. Okay, now imagine another situation. A friend came to his friend and said, I have only chocolates I have chocolates, will you eat? Then say, yeah, of course, I wanna eat, I love chocolates. Another friend said that I don't have anything to give you. But if yet you want to share your chocolates with me, that's absolutely fine. And friends say, it's okay, we are friends. Take this chocolate and let's enjoy it together. Similarly, these bondings are two types. One is if atoms, we both atoms are sharing the electron to each other. Okay, how? Let's say this this have one electron and this have one electron. This have one electron. A have one electron, B have one electron. They are sharing the electron and making this possible. Both are sharing their one electron and completing their octet. And this is called covalent bonding. How covalent bonding? Co means cooperative. Valence means valence electron. Valence electrons are cooperating with each other. How? Via bondings. That's why it is called covalent bonding. Second one is A have two electrons, two chocolates. Two electrons, two chocolates. B have nothing. Yet A is giving his chocolates and sharing his chocolates with B and making a bond, making their friendship. They're making their bond stronger, making their friendship stronger. And this kind of bond is called coordinate bonding. Coordinate bonding, also known as dative bonding. Dative bonding. Okay, dative bonding. Those compounds which holds chemical bonding are called covalent compounds, and which holds coordinate bonding or dative bonding are called coordinate compounds. And this coordinate compound holds a complete chapter in 12th class, which is called coordination compounds. Okay, so by all these things, to explain the how octet completes, we conclude that there are three types of compounds. One is those who holds ionic bondings between ions, called ionic compounds. Second one, who holds covalent bonding by sharing their mutual sharing of electrons, are called covalent compounds. And third one are who donates their electron to another atom's valence shell orbitals, empty valence shell orbitals, which are called coordinate bonding, and compounds are called coordination compounds. That's how we can classify the types of compounds on the to start with octet rule. I hope you guys like it. And causal level structure we will study in next chapter. Up to this, revise this, study hard, and stay focused. Have a good day. Keep growing. Thank you.